Hello students, so this is the video, the first video of your machine drawing lab. So we will quickly go through the type of projections, okay, for any machine part. Okay, now first of all we need to know about something called machine part, okay, or component. Alright, then something called assembly. Alright, so here you see machine part is something which will be a single piece of a machinery. Let's say, just consider a machine, anything, okay, that any designer or someone who makes any you can say anything which reduces the effort, okay, by virtue of conversion of energy, okay, which reduces human effort, or which reduces, let's say, which does some useful work, okay, those are machinery. They employ mechanisms. A machine employs mechanism. Now machines consist of, okay, more than one part or component. Okay, now consider any simple machinery, let's say belt drive, belt or chain drive. You consider chain drive because it is more familiar to you. Chain drive. So in a bicycle or a bike we have something like this, okay, and there's another one, bigger one or smaller one. These are two saw-toothed wheels, okay, you have seen this, and we connect them using spring, not spring, sorry, the chain. So here these are the parts, okay, three parts are here, we say machine parts or components. This is called sprocket. So this is sprocket 1, this is sprocket 2, and this is chain. So here you can see that there are three different components. By the way, you can say sprocket both are same, but still they are separated, they are not one part. I mean, if you just remove the chain, then you can rotate them freely. If you rotate sprocket 1, then sprocket 2 is free now without the chain. If you connect the chain, then sprocket 1 will transfer its your motion to sprocket 2 with the help of the chain, okay, like this. All right, so now a part or component is something where there's only one machine, I mean, say only a single machinery piece is called a part or component. Now here sprocket, here only the, if you consider only the sprocket 1, that is a part. Sprocket 2 is another part. Sprocket 3 is the chain is another part. By the way, chain is another part, actually that is not exactly true, because chain is a combination of small links, okay, and they move with respect to each other. So chain is actually not a part, okay. The correct thing is chain is an assembly. Actually the assembly is something where we connect all the parts to get the complete, you can say, machine. So chain itself is an assembly of parts. There are small parts are there. Now you can see, that's why you consider two pulleys and one belt. Here belt is actually a flexible drive, and belt is considered as one part. This is another, the pulley is another part, pulley is another part. So this is just to show you the difference between part and assembly. Okay, now in our machine drawing lab we will be drawing, okay, the views, okay, views of parts first, and then, okay, the views of assembly drawing. Now since assembly drawing takes time to draw and you need the knowledge of all the parts, so we'll start with parts. So most of the you can say drawing will be based on parts, okay, and the last drawing will be for assembly, okay, assembly. Now consider uh, any part. Now what are the views for any machinery part? See, we have learned in engineering drawing that we can draw the projected views of anything, like for point, for a line, for a surface, and for a solid. Okay, so here we will first start with that type of view for a solid. Okay, solid object, three-dimensional object, right? So you have learned in engineering drawing some views in the planes. Now projection planes are something. Okay, projection planes or planes of projection, we need to, let's say, let's understand projection in the planes. So there are 4 quadrants. All of you agree? So these are the quadrants, four quadrants. So actually this is quadrant number 1. Okay, here it is 2, here it is 3, here it is 4. So you understand this, right? So this is origin here. Okay, let's say this is a x-axis. Okay, so this will be y-axis and this will be your z-axis. Okay, now if you place any object in your first quadrant here, let's say we place something like this. Okay, so let's consider so for this object, okay, this one, right? So if we view exactly at the level, let's say this is kept at the height of some let's say anything, let's say 10 centimeter from this plane. Okay, this xz plane, right? So if you are present here in this plane itself and you are viewing exactly, your eye is, this is your eye, and your eye is exactly at the level of 10 centimeter, same height. Okay, then this you will be looking at this face of your object, this face. Okay, so this is called orthographic view. Orthographic. So when you are looking exactly perpendicular to any surface of the body, or you can say you're not I mean you have placed your object exactly in front of your eye, that will be orthographic view. Now if when you draw its projections, one of the projection is nothing but, you can think like your eye is a torch or some light is light source is here, and when you throw light here you will get a shadow, and that shape of the shadow here is the projection. But the projection will have thick lines, thin lines, okay, dotted lines, center lines, okay, and you can say zigzag lines, all the lines. Okay, so I hope you know the uses of these lines, because you have learned it in engineering drawing. We will be going to use them here. Okay, so if you do not know, please go through the videos that I have given you and you will get the basics of this. So now, or someday I'll tell you about while drawing it, while we draw some drawings, while I show you the parts, drawing parts, then I'll explain about these lines. Okay, now see, when now you're here, you will be viewing this from this side, so you'll get a view like this. So now if you exactly come above this, okay, now you're viewing from here, you're at the top, but you're exactly your object is exactly in front of your eye. Okay, in front exactly means you may be standing at a very I mean here also somewhere, I mean at a distance, not a problem, but you can say that your viewing line is parallel to any of your plane. Now in this case it is parallel to, okay, your viewing line is parallel to your plane, this plane, xy plane. Here also viewing line is parallel to this yz plane, that way. Okay, you may be standing at any place, no problem. So now if you view from here, your view the projection will come in this plane. Okay, like this. So this is actually, since you are at the top, so this is called top view, and here at this position you are here, so this is called your front view. Okay, fine. So one thing that you have heard about first angle projections, I think, first angle projection and third angle projections, because these things are also basics and you have learned in your engineering drawing. So first angle projections are obtained when you place your object in this first quadrant. Okay, and third angle projections are obtained when you place the same object in your third quadrant here, right here, let's say. Understood? So now you see, one thing you keep in mind, that you cannot go anywhere beyond this plane. Okay, this plane, you can say this will be your, this is x y, this will be y, this is y, this is y z, sorry, this is xy plane only, minus y x plane or xy plane, or you can say your plane bounded by y and x. Okay, so this thing, I mean, you cannot go beyond this one, you cannot cross this plane. Okay, this plane here anywhere you cannot cross, so it will be here anywhere, but you cannot go that side. Okay, so now you see, if you are here and your object is here, if you cannot go that side, okay, I mean that side, so you will be viewing from here only. Okay, your eye will be here exactly parallel to this plane, no problem, but in between your eye and the object, this plane will interfere, this plane, right? Okay, but here what we do is we still draw its projection similar to that. That means you think like this is transparent, this is made of glass, this part, and you'll still see the edges of this one. So whatever you see, you draw this here actually, huh? So this will be the view projection of this one. Okay, understood? So you are here. Now one more thing, actually I'm sorry, I should have told you, you cannot go beyond this plane, not I mean only below this line. Okay, I'm in the negative zone, you cannot come here, but above you can actually go. I'm sorry for that. So this you can view from here. Okay, but you cannot go below this, I mean you cannot view from this side. Okay, you can view only from that side. Actually I'll tell you the reasons why we do this. Okay, and that is the why we follow this type of actually our method to view this. Okay, I'll just explain that in the next page. This page has got dirty. So here you see this, from if you view from that side, so you will get its projection on this plane. You can again think that this plane here is, this plane is transparent, and you will view this face, the face, this face here, so you will come here. Okay, so now I'll tell you why we view from here. Okay, and here and here and here. Okay, this position here. All right, so let's go back to the planes. Okay, understood this. Now you see, now since this is a paper, right? Okay, right, so in the paper, can you draw, see, if I show you the quadrant, this is the quadrant, right? First angle projection, this is the quadrant. See, quadrant is like this. All right, okay, so this is your z axis and this is your y axis. If you place your object here, okay, let's see, this mouse is the object. Okay, here, that's projection front view, and now this is the plane. Okay, plane, you can consider this plane is your xy plane, vertical plane, this one, and horizontal plane here is your xz plane, and this is your object. Now if you view from this side, okay, this side, exactly in front, you have to your eye should be parallel to this plane. Okay, the viewing side viewing line has to be parallel to this plane here, bottom plane, the horizontal plane, and you'll be viewing this face of your of the mouse, this face, and you will draw that projection here in this plane. Okay, here, fine. Okay, I mean consider the paper, huh? Not the picture here, the paper. So it will come here, and your top view will be viewing from this side, from the top. Okay, from the top here. Okay, like this, and it will come here. So it will view this surface. So it will come here. Okay, now you have to draw them together in a piece of paper. What will you do? You can either draw any one of them. If you draw here, then you cannot draw, because you will just project a paper like this? No, your paper is a plane, only one plane. Here I am drawing it, this everything in one plane. I do not have a paper like this, or anything like in a drawing sheet. So what we do, you see, this is the mouse. Okay, right? Okay, or whatever object we have here. Okay, so the front view is this one, and the top view is this one. Okay, you agree? Now since you have to draw only you have to draw both the views in one plane, so let's draw this line first. This is the line. This line is the line of, you can say, line we obtain by crossing both the planes. Okay, so this is called XY line. If we consider this as x axis, this is y axis. Okay, XY line. Okay, all right, so let's draw XY line. Okay, and the front view, right? So now actually our top view should be here, right? Here, isn't it? So can you draw that? No, because your your paper is here exactly, parallel to, or paper is the, this side is also parallel to the above side. Okay, that means to draw these two together, what you have to do is, you understand, what you have to do is you have to rotate this plane. Okay, rotate the whole plane. Consider this as a pivot or a pin joint here. Okay, consider this as a pin joint, and rotate this plane completely to merge it along with vertical plane. Understand? So merge this plane here with this plane. Okay, so rotate it completely 90 degrees. This is 90 degrees. Rotate 90 degrees. This plane will merge with this plane. Okay, this plane will merge with this plane. Okay, so ultimately there will be only one plane. Now what will happen after merging? You see, this is the front view. Okay, and this is the top view. Understood? Okay, so here this is the front view we have drawn, and this is the top view. All right, is it clear? Yes. So this is for first angle projection. What will be for third angle projection? Now see, for third angle, this is first angle, and this is third angle. So if you keep the mouse at third angle here at this point, okay, so you will get front view here. Okay, let's shade them so that we can differentiate. So this is the front view, and this is the top view. Understood? Okay, so now this is front view. Let's write as F here. Top view means T. Now since you have merged this plane here, we have taken this plane above, and this plane is there itself. Okay, we are not changing this plane. So in third angle projection, see, front view is below XY line, isn't it? See, below, it is below XY line, so it will come here, front view. Okay, and this portion is, this part is top view. Okay, understood? All right, so front view, top view. Okay, fine. Now you see what is the difference. Now we have seen, first of all, in first angle, front view is above XY line. Okay, top view is below XY line. And for third angle projection, top view is above XY line and front view is below XY line. But for your help, you always please follow first angle projection throughout your diagrams, your class assignments, and your exam. In your exam also, please follow first angle projection. Okay, now these are two views, front view and top view, we have learned. But what about side views? Okay, there are views from the side also. Okay, now for that you consider a box. Now that means we have to enclose your planes. Now see, if you have the view from the side, now see, look at this. I think till now you have understood the placement of the object and how we have obtained the projections just by looking from the front and looking from the top. If you now look from this side, right, this side, where will the views lie? Yeah, views will come here somewhere, but they must strike at something, right? So this side is open, this side is open, right? Okay, where will the view lie? We do not know, so we must close this side. Okay, so close it. Understood? We have closed. Now since we have closed it, so we have obtained a plane here. Understood? And this view will come here somewhere. Actually all are black, so this is the view. Just imagine how we, from this side, if you view like this, then we'll see the view here. Top view will be here only. See, top view is not changing, front view is not changing, but this is the side view. Okay, side view from this side. Now we must actually name the side views, because we can have the side view from this side also, from this side also, opposite side also, this side. Okay, from here also you can see, from here also you can see, right? Now depending upon your position, now you are the person here. Okay, you are here. Okay, you are moving from here, from this position to the top, from this position to that side. You are moving from this position to this side. Understood? Okay, so since you are moving, you consider that you are facing this side. Okay, this side, you are standing here, you are here. Okay, you are the person and you're facing this side, understand? So this is your right hand, this is your left hand, right hand, left hand. Okay, right, left. So if you go towards your right here, okay, and you view from that side to get the side view, this is called right side view. Understood? If when you move to your right, but this is opposite in your I'm sorry, just a moment, will be here. Yeah, that will come to third angle projection later. So here when you see first angle position, when you are here, okay, so if you move to your right side and get the side view, that is called right side view. Okay, now how will we show the same view in this plane? Because we are showing it in this plane, right? That's why we have rotated this plane to merge with the vertical plane. So we are actually drawing the vertical plane here, everything in vertical plane. So we have managed somehow to draw the top view here, right? Because we have merged the horizontal plane with vertical plane. Now what will we do to draw this side view? Because the side view here, actually it is lying here like this. So can you draw it? No, but you have to rotate this plane also with merge with your, also to merge with your vertical plane. So what you have to do is, I'm showing it with black, so just rotate this whole plane, the green one, okay, to merge completely with the vertical plane. It is like this. So look at this, this is the plane, right? The green plane here. So rotate completely to merge with your this plane here. Okay, so this comes with this, so this side matches with that side, this edge comes here. So this is your green plane now, new green plane. You understood? I think now since your plane has come here, okay, now that side will go that side, so your object, this view also will come here. Okay, this is the right side view. Okay, so it will be above your xy line. So your right side view is now here. Okay, this is right side view. Clear? Okay, fine. I think it's clear for you. So now the left side view for this one. Now what you have to do is, you are here, you come to your left hand side, okay, and view from this side. We do not have any plane here, so we must have a plane that side. So for that, let me take the blue one. So we have a plane, let's say that side. Understood? So this, its view will lie here. This is your left side view. Understood? You are viewing from this side and you will get a view from this side and it at that plane. Similarly, again you have to rotate this plane 90 degrees to merge with the vertical plane, and this view will go here. Understood? So your right side view will be now, left side view will be here. Left side view. So everything above xy line. So this is the complete projection of the object, that is orthographic projection. Orthographic here. Okay, front view here above xy line, top view below xy line, right side view. Okay, don't get confused with your, I mean, you're drawing here, this is your drawing, and you are a right-handed person, you should draw the right side view here. No, that is not the case. It will come here, this side. Okay, right side view, and your left side view is where, because it depends upon your position. Okay, now similarly, if you keep it in your third angle, what will happen? You, let's see. So now your mouse is here. Okay, this is your top view, front view, and this is the top view T, this is F. Let's from top view and front view. Okay, understood? Now we will merge this and we'll get the top view above xy line, front view below xy line. Okay, now you're here. Now you're again here, and you'll go that side. Now you'll go get your, you see, this object is actually below xy line. Okay, so your right side view will be here. Okay, let's draw it with some black. Yeah, this one here, and this will, okay, this is the plane. Now this plane you must rotate, okay, in this manner, so that it merges with your vertical plane. Okay, similarly, now this is the right side view. Let's draw them. This is xy line. Okay, fine. Front view is below xy line, front. Okay, top view is above xy line. Okay, so your right side view will be in a similar position, but actually this is what I was talking about. It's not opposite, but this will come below xy line. It will come below, because your object is below xy line here. You see, this xy line, object is below. This is the actually plane, xy plane. So again, if you, when you move to your left, okay, your left, and you view from this side, okay, then it will strike there. So you have to rotate this plane like this. Okay, so that you get your view here. So your left side view comes here. Okay, for third angle position. Since you are not following this one, so I'm not explaining it in detail. I think this much will be sufficient for you to understand. So we are not actually going to follow third angle projection, right? All right, okay. Next is, let's start with some examples of orthographic projections. Okay, before that, let me tell you, orthographic projections are something that we are going to draw here and everywhere and in your drawings. There are 3 more projections. Okay, then isometric projection is there. Isometric, you have understood what is isometric. Isometric is when we draw any object, okay, at an angle of 30 degree. Okay, one of its edge will be at an angle of 30 degree, and this edge will be 90 degree. So this is 120 degree, 180 minus 120, this will be 60 degrees. So one of the edge must be kept at 30 degree to a line, to this line. Okay, this is isometric view. Then we have oblique view. Okay, oblique is something when here, this was the previous diagram I was showing. When you are not exactly looking parallel to the plane, you are actually, you have come away. I mean, you are parallel here, sorry, I'm sorry, you will be parallel, but you are actually coming, you'll come this side, so that you can view from this side. Okay, then your projection, this part goes there, that side. Okay, from here, I'll actually I should show it in a so clearly later. Okay, so I'll tell you about this oblique and isometric, okay, in a better way later on. Now there's another view at the end, that is called perspective, and this is actually for interior designers, okay, or normally for decorators. This is very important. Even people who do your drawings, okay, paintings, they know actually the perspective projections. Perspective projections are actually the reality, the real projections. Okay, in real life we get this perspective one. All right, so examples like this, you see, you are here inside a room, long room. Okay, this is the room. Okay, here you are inside you are here, standing here. Okay, you are the person here and looking that side. Okay, that side. Now these two edges of the room, look at these edges, edge 1, edge 2. Okay, edges of the room, these are the edges. Okay, now when you are here, these two lines are parallel. Okay, no problem. Okay, but when you're standing here at this position, and you will not view exactly parallel, these two lines will not appear parallel to you, they will appear like this. Okay, if you agree with me, the other end of the room will look like this to you, isn't it? These two lines, they are going to meet each other at some, I mean the room is long enough, just consider like this. This side is the opening, that side. Or let's say you have something here, let's say you have a table here. Okay, so this is the table here. Okay, so this room will appear like this, the edges will, they are going to meet them, it will appear they are going to meet them, but actually they are not, right? So the railway track also, railway track, that these two rails are not going to meet anywhere, okay, later on. But when you stand in the railway track and look, then they appear to meet at one point. Okay, at infinity. So these are actually past. See, now these are actually our view. Okay, from our perspective we observe and we actually see it like this. Okay, now how to draw them in a real life? Here you see, since this is actually a lot of things I have explained here, so how to draw perspective position, I'll simply tell you, you have to move your position, okay, from in this angle also, in this angle also. Okay, and you have to come here somewhere so that you see an enlarged portion. Okay, better to show you, I'll show you with some example. Okay, and I'll take a class especially based on perspective projection later. All right, so in the next class we'll do some examples of orthographic projections. Thank you.